Hey class, this is Ms. Richardson, and today we're going to talk about more linear equations, which is found in section 2-4, part 2 of your book. Our objectives are to write and graph the equation of a line and to write equations of parallel and perpendicular lines. In example 4, we are asked to find the intercepts of 3x plus 5y equals 15 and then to graph that equation. If we can remember the definition of an intercept is where the line crosses at that axis. So if I have a graph, remember this is the x-axis, this is the y-axis, and if I am to graph, let's say this point, whatever it is our x-intercept, and the form of that ordered pair would be whatever our x value is, comma, 0. And this ordered pair would be as an ordered pair would be 0, comma, whatever our y value is. So in other words, to be able to find the intercept that we're looking for, we have to set the other variable equal to 0. So for example, if I'm trying to find the x intercept, I would have to set y equal to 0. And if I'm trying to find the y-intercept, I would have to make x 0. So let's see what this looks like if we try to solve finding intercepts. So I'm going to erase this. Okay, so if I start by writing 3x plus 5y equals 15. Let's say I want to start by finding my x-intercept. Okay, remember to find my x-intercept, which is the form x comma 0. That means I need to make my y 0. Okay, so that's what I'm going to do. So I'm going to have 3x plus 5 times 0 equals 15. We know that anytime you multiply a number by 0, it becomes 0. So let's just ignore it. And so now we have 3x equal to 15. To find my x-intercept, I would divide by 3. And x will equal 5. So our x-intercept would be 5, comma, 0. Okay, so that's the first part. Now, if I want to find my y-intercept, I'm looking for the y value when my x is 0. So do the same thing. So I would have 3 times 0 plus 5y equals 15. Anything times 0 is 0. So then I would have 5y equal to 15. Finally, if I divide by 5, y equals 3. So in other words, our y-intercept is 0, comma 3. Finally, we're asked to graph. It's a tiny graph, so I'm sorry. But let's say I just make some tick marks along the sides. Our x-intercept was 5, 0. So on the x-axis, I'm going to go out 5 to my right and plot a point there. Our y-intercept is 0, comma 3. So if I start at the origin, I'm going to go up 3, and here's my point there. Finally, I would just connect those two, go further, and draw arrows at the end. I know in class I always say 3 points make a good line, but remember at bare minimum 2 points do make a line, and in this case 2 points will make a line. So we have now found the x and y intercepts of 3x plus 5y equals 15. So let's try it again. We're asked to find the intercepts of 2x minus 4y equals 8 and then to graph. So again, we are, oops, not plus, minus 4y. We're going to find the x-intercept or the y-intercept by setting the other variable equal to 0. So I'm going to start by finding the y-intercept. So that'd be, or excuse me, the x-intercept. So I'm going to say 2x minus 4 times 0 equals 8. That will go away. I'm going to have 2x equal to 8. If I divide by 2, x equals 4. So our x-intercept is 4, 0. If I do that again, I would have 2 times 0 minus 4y equal to 8. Anything times 0 goes away, so I have negative 4y equal to 8. If I divide by negative 4, y equals negative 2. So my y-intercept is 0, negative 2. So when I go to graph, I need to go out at least to 4 on the x-axis. So 1, 2, 3, 4. And on my y-axis, I need to go down 2. So down here. And that's a bad line, but it works. And so that's our graph. Remember, if this were a quiz, I would expect my better expectation is that you write it as an ordered pair. So that would be my x-intercept, that would be my y-intercept, and then our graph. If you wrote x equals 4 and y equals negative 2, understand that these are actual lines. So the better answer is to write it as an ordered pair. Okay? Here we have a little bit of vocabulary. I'm talking about parallel and perpendicular lines. So we're shown that properties of parallel lines are that the slopes are the same. So we will have different y-intercepts, meaning that's why I have a b1 and a b2. There'll be different y-intercepts, but again, we are told that the slopes are the same. With perpendicular lines, we have slopes that when multiplied together will give us negative 1. And instead of trying to figure out, well, what two slopes can come up to give us negative 1, we often say that the slopes are opposite reciprocals of one another. So as an example, if I have 1/2 as my first slope, to find my other slope, I will then find the opposite, then the reciprocal, and that would be my new slope. So the opposite of 1/2 is negative 1/2, and the reciprocal of negative 1/2 is negative 2. So this would be my new slope. Let's say I have a different slope. Let's say I have a slope of negative 3/5. The opposite would be positive 3/5, and the reciprocal would be 5/3. So this would be my new slope. Okay, but we'll practice that in our upcoming example. Okay, so in example 6, it says, what are the equations of the given line that are parallel and perpendicular to y equals 6x minus 2 through 1, negative 3? I would like to start with parallel lines first, because with parallel lines, we know one thing for sure, and we know that your slopes are the same. Now, luckily for us, this equation is given to us in slope-intercept form, meaning our m is slope. So all we have to do is look at the equation and we know our current slope. So our current slope is 6. And so our new slope will also be 6. Now, this new slope, along with this point that we're given, is the information that we will use to create our equation. We're going to use slope-intercept form because it's the easiest to use. So here we go. Remember, we will start by, first of all, here's the information that we're looking at. And then we will start by writing our slope-intercept form. That's y equals mx plus b again as a reminder. And then we substitute in the information that we're given. Remember, 6 is our m, our slope. 1 is our x, and negative 3 is our y. The only thing then that we will be looking for is b. So here we go. Y is negative 3 equals 6 times 1, because that's our x, plus b. Be careful because 6 and lowercase b can kind of look close alike, so pay attention. So negative 3 equals 6 plus b. I'm trying to get b by itself, so remember, in order to move, I'm going to subtract. So b will equal a negative plus a negative is a negative, so it will be negative 9. So our new equation will involve our slope and our new y-intercept. So that equation will be y equals 6x minus 9. So that is the equation that is parallel to our original equation that goes through our point 1, negative 3. Okay? So now we're going to find the line that is perpendicular to that equation and through the point 1, negative 3. So again, let's start off with the information that we know. The information that we currently have is that our slope is 6. We're talking about a brand new situation. We're talking about perpendicular, but we're still talking about the original equation. So yes, our slope is still 6, but our new slope that we're worried about has to be the opposite reciprocal of 6. So let's go through that process. Originally it was 6. The opposite is negative 6. The reciprocal is negative 1/6. So we will use this slope and this point to write our new equation. So here we go. Y equals mx plus b. Y, remember, is negative 3. Oops, excuse me, not negative 3. Yeah, negative 3, I'm sorry. Y is negative 3 equals, our slope is negative 1/6. Our x is 1 plus b. So we'll have negative 3 equals negative 1/6. It's supposed to be negative, plus b. I would have to add 1/6 over. So now we just have to do the work for that. Remember, negative 3 is the same thing as, and I'm actually going to draw it up here. It's the same thing as negative 3 over 1, right? And I need to find a common denominator, right? A common denominator with 6. So to get to get 1 to be 6, I would need to multiply both the numerator and the denominator by 6, which will give me negative 18 over 6. So really what this setup is negative 18 over 6 plus 1 over 6, which is negative 17 over 6. So our y-intercept is negative 17 over 6. You don't have to change it back to a mixed number. So our final equation there will be, using our new slope and our y-intercept, it'll be y equals negative 1/6 x minus 17/6. Now, the only reason why this looks so funky is because we are dealing with fractions at this point. And yes, those get really complicated and things like that. But be sure that we can find common denominators and then continue to solve the problem. So let's try this again with try 6. In try 6, we're asked again to find parallel and perpendicular lines to 4x plus 2y equals 7. Now, what's not so great about this originally is that we cannot look at this equation and know what our slope is because it is in standard form. So if you remember that, standard is ax plus by equals c. So we need to change it out of standard form and go ahead and write it in slope-intercept form. So let's practice converting. So if I have 4x plus 2y equal to 7, my goal, if I'm trying to do slope-intercept form, is to get y by itself. So I need to subtract 4x on both sides. And I will have that 2y is equal to, if I put it in order, negative 4x plus 7. Finally, to get y by itself, I divide by 2. I can't show dividing by 2 unless I start writing on the numbers or the words. So I will have y equals negative 4 divided by 2 is negative 2, so it's negative 2x plus 7 over 2. So this is the equation that we care about, and more specifically, this is the slope that we care about. So let's talk about parallel lines. So if it's parallel, that means our original slope is given to us as negative 2, which is also the slope of our new line. So we will use that slope and the ordered pair for negative 2 to create our new line. So here we go. If we use y equals mx plus b, y is negative 2, m is also negative 2, x is 4, and we're adding b. So negative 2 equals negative 8 plus b. Again, to get b by itself, we're going to have to move 8 over by adding it. So b will equal 6. So our new equation with this slope and this y-intercept is y equals negative 2x plus 6. That's the start. So that's for parallel lines. Now let's practice with perpendicular. Remember, with perpendicular, our original slope is negative 2, but our new slope has to be the opposite reciprocal of that. So the opposite of negative 2 is positive 2, and the reciprocal of positive 2 is 1/2. So we're going to use that slope and again the ordered pair for negative 2 to write our new equation. So here we go with that process. Again, y equals mx plus b, just so we're putting things in the right spot. Y is negative 2, right? Yx. Y is negative 2 equals 1/2 times 4 plus b. That means that negative 2 is equal to 2 plus b. If I want to get b by itself, I'm going to need to subtract 2. So b will equal negative 4. So to finish that, if I'm using my new slope and my new y-intercept, my line that is perpendicular to the original line will be y equals 1/2 x minus 4. And we're done. Be sure to complete your homework, and remember, if you have any questions, come see me for tutoring. Bye guys.